Hello guys, this is Paul McWhorter with TopTechBoy.com, and we're here today with episode number 9 in our incredible new tutorial series where you are teaching your Raspberry Pi who's boss. What I'm going to need you to do is pour yourself a nice tall glass of iced coffee. That would be straight up black coffee poured over ice, no sugar, no sweeteners, none needed. And as you're pouring your coffee, as always, I want to give a shout out to our friends over at Sunfounder. Sunfounder is actually sponsoring this video series of lessons, and we will be using the most excellent Sunfounder Ultimate Raspberry Pi Kit. Now, believe me, your life and my life are going to be a whole lot easier if we are working on identical hardware. Hopefully you already have your gear put together. If you don't have your gear yet, look down in the description. There is a link over to Amazon where you can pick up this most excellent kit. But enough of this shameless advertising. Let's jump in and let's talk about what I am going to teach you today. And today, I think, is the day that things really get interesting. Now, they have been interesting, I think, the last few lessons. We're getting in there and we're really starting to bang on those old GPIO pins. We've learned how to send signals to the GPIO pins. We've learned how to read signals back from the GPIO pins. We've had some pretty cool demonstrations where we could like turn an LED on and off based on using a push button switch. That's been some pretty interesting stuff. But today we're going to take it to the next level. And what we're going to learn to do is we're going to learn how to put PWM signals to the GPIO pins. Now, what is GPIO? GPIO is general purpose input output. What is PWM? It is pulse width modulation. And what pulse width modulation does is it allows you to take an inherently digital system and it allows you to simulate analog voltages. Now, the truth is digital systems only have two choices. They are on or off. They are high or low. They are 1 or 0. They are true or false. There's no in-betweeny. There's no in-betweeny in digital, okay? So when we were working with the LED in the earlier lessons, what could we do? We could turn the LED on or we could turn the LED off. Now that is pretty exciting, but I will admit sometimes you might want to, like, let's say, have a light dimmer where you dim the LED in increments between all the way off smoothly up to all the way on. Sometimes you want the in-between values. And the problem is you cannot get in-between values just using something like the Raspberry Pi and just using something that is a digital signal. So this is where PWM or pulse width modulation comes to the rescue, because it is true still on or off, but we're very clever in the way that we turn things on and off so that we can simulate analog signals. Now let's see here. Let me I'll have to do a little Windows management here. I always like to switch over and show you my studio view just for a second so you can kind of see how things are looking in the studio. I'll probably go ahead and get out of your way here for a second. And then what you can see is I've got something new to show you today. I have got a digital oscilloscope. And what that oscilloscope is going to be able to do, it's going to show us the signals that we're actually getting off of our GPIO pins when we set them up for PWM. Now, if you have an oscilloscope, by all means, hook it up and use it. Okay, if you don't have one, first of all, I know a lot of you would not be able to afford it. It's probably a couple $100, but let me say that if you guys are really serious about electronics, you need to start building your lab. And building your lab is more than just buying the latest and greatest single board computer. Building your lab is starting to get equipment that you need, like a good oscilloscope or like a good soldering iron and things like that. You need to start putting together your equipment for the lab. So if you have the coin, you can go ahead and order one of these. I've looked at a lot of oscilloscopes. This one was about $200 and it's a very full-featured oscilloscope in a good hobby model. A real oscilloscope would cost anywhere from $2,000 to $20,000, but for the home bench, this is a really good value at $200. Got a link down below to the one that I'm using. Okay, a lot of you guys don't have that kind of coin, and you're just going to follow along with the Raspberry Pi. That's okay, because you can completely do everything I'm doing. You're not going to miss out by not having an oscilloscope. It's just because you can look on my oscilloscope and you can see what's happening, but you're going to actually hook up your Raspberry Pi. You're going to do everything that I'm going to do. You're just going to do it without seeing the results in front of you as far as the oscilloscope goes. But enough of this introductory banter, just way too much talking and not enough coding. And so let's jump in and let's see how PWM works. What I have here is I have set up a little graph, and what we're going to do is we're going to look at voltage over time. All right. Now, what we can do is we can come in and let's say that today I am working on the most excellent, it looks like GPIO pin 37. I could come in and I could turn GPIO pin 37 on. And what would it do? It would come up here to 3.3 volts. That's rather odd. Okay. Come up here to 3.3 volts. And come across, and we could turn it on. Okay, we could turn on that GPIO pin and get 3.3 volts. Or we could come over here and then we could turn it off and the voltage would go to 0. So we can sit and we can turn the GPIO pin on, or we could turn the GPIO pin off. Does that make sense? Okay, but now what I really want, let's say I wanted the LED half brightness. Well, instead of 3.3 volts, what I would really want would be about 1.5 volts. You see, this is what I want here. I want about 1.5 volts for half brightness. The problem is my only choice is on or off. And so I can't turn it half on. Okay, I can't turn it half on, but I can turn it full on for half the time. And believe it or not, full on for half the time is almost the same as half on. So what would that look like? That would look like I would turn it full on, and then I would turn it full on, and then I would turn it full off, and then I would turn it full on, and then I would turn it full off, and then I would turn it full on, and so forth. You're going to get tired of me repeating myself, but I hopefully that'll help you understand it. And then if you look at it, what is the average of the signal that I just put on there? The average is half. And that average voltage, it kind of acts the same way as if you had just set it there. All right. And so that's what we're going to do. This works for a lot of different things. It'll work for LED brightness. It'll work for motor speed and motor control. There's a lot of things that this PWM will actually work for. And so that is what our task today is. Our task is to figure out how to do this PWM. Okay, also, I guess I should say you don't just have to go, like at half. What you could do is you could come on for, say, 10% of the time, and then off for 90%, and then on for 10% and off. You see, what you're doing is you are modulating the pulse width, and you could have it on for like 1% of the time, 50% of the time, 99% of the time. If you turn it on at 100% of the time, that would just be a DC or off at 0. But you see, you could go anywhere in between those, and then you can kind of get something to start acting like analog out. And so let's see if we can get that going. We're going to have to come over here. I'm going to have to figure out which window would be the best window for you to see. Let me do a little switching here. One of the problems I have is I have more high-resolution cameras in my system. I have more high-resolution cameras in my system than I have input ports on my computer, so I'm actually having to switch cameras between ports, and that makes things even a little bit more tricky to try to keep this studio running well for you. Okay, so let's come over And let's see if I can start with an overhead view. Let me see if I just got a good overhead view so you can kind of see what we are dealing with here. Okay, so I've got the Raspberry Pi, and I have a simple LED circuit hooked up, and then I have an oscilloscope up here. Well, what you need to do is you need to go ahead and hook that LED circuit up, and let me see if I can find it. Yeah, this looks like the circuit that I have here in the schematic up here. Today we will be using the most excellent pin 37. That is on the left column, and that is the second from the bottom GPIO pin. That's pin 37, and then we're using pin 39 as the ground. And so we could come over here real quick, and you can look at the pin out, and you can see 39 is the lower left pin, that is the ground. 37 is one up from that, and that is the GPIO pin that we will be using, okay? And so what you're going to do is you are going to then come over and hook up an LED. So we go from pin 37 to the long leg of the LED, and then the short leg of the LED goes through a 330 ohm resistor, and then the right leg of that 330 ohm resistor brings it on home to pin 39, the ground. Okay, you guys probably already have something like this hooked up, or if you don't, it will just take you a second to hook it up. So that is our setup. Then what I'm going to do is I'm going to start sending PWM signals to the LED through pin 37 on the Raspberry Pi. And that's what you guys are going to do. But then what you're going to do is you're also going to see what you're going to see is you're going to see the effect of the PWM on the LED. But what I'm going to do is I'm going to get the probe from the oscilloscope, and I'm going to grab that pin 37 by hooking to the long leg of the LED. And then I am going to grab the ground by hooking right here. And now I have that. And now I need to do a little bit of management here. I think, let me look, that looks like 200 millivolts, 1 volt per division. Actually, that looks pretty good as far as trying to get it to do what I want. Okay, so I've got the oscilloscope and the LED hooked up. Hopefully, hopefully you guys now have your circuit set up, your LED set up. Now what we're going to do is we're going to come over here to a new view where we are looking at lots of different things at the same time. And let's see if that looks good. Yeah, I think that looks good. So you're going to be able to see my code, and you're going to be able to see the oscilloscope, and you're going to be able to see the LED. Pretty slick, huh? Pretty slick. So let me come over here, and then I think what we'll do is we'll go ahead and move this to the top by doing a quick clear. Okay, and now we're going to go ahead and instead of writing a program, what we are going to be doing is we're going to be working in the command line, okay, the Python shell. And so to get there, I type Python, right? No, that puts us into Python 2.7, and I think I did that by accident in lesson number 5, so I'm sorry about that. Don't use Python 2.7. We're going to quit out of that. We're going to clear again, and it's what that we're working on. We are working on the most excellent Python 3, which is Python 3.7, and we are ready to start banging on those GPIO pins. So what's the first thing we're going to need to do? I'm going to need to import our old friend rp_i.gpio. I'm going to import that as what? GPIO. You can import it as kitty litter box if you want to. I think it would be more meaningful and easier to write every time if we imported it as GPIO. That is a great coffee we got there. Okay, boom, we got the import. That always makes us happy. Now we need to do the set mode, and that tells the Raspberry Pi what numbering system we are going to do. It will be GPIO because that's what we imported it as, and we are going to use the board configuration. What's nice about the board configuration, if you want to use pin 37, you call it pin 37. Kind of makes life easy, doesn't it? Okay, we got that one. Now what we need to do is GPIO.setup. What are we going to set up? Pin 37, the most excellent pin 37. And then that's going to be a GPIO.out. So far, everything is kind of very familiar, isn't it? Everything is very familiar. All right, so let's go. Boom, that looks good. All right, so now let's just kind of check things out, make sure that everything is in proper order. Atoms in the universe are in the proper place and everything. So what I'm going to do is I'm going to go ahead and just do write a true or write a 1, and we're going to watch the LED come on, and then what we should see up here, we should see this line come up, 1, 2, 3.3 volts. I've got 1 volt per division. I don't know, you might not be able to see the divisions real well, but it'll be 1, 2, 3, and then a little bit more than 3 would be 3.3 volts. This is not PWM, this is just good old-fashioned DC, but we should see it on the oscilloscope. Now, also this oscilloscope sometimes like auto modes and things like that, so I might have to go in and tweak the oscilloscope to get the signal on there, but we should certainly see the LED come on. So how would I do that? You guys should know this already. We are going to do a GPIO.output. We're going to output to what? The most excellent pin 39, and it is going to be a what? Let's do a true. We're going to put a true like that. Okay, everybody hold their breath. Boom, we got the LED to come on, but we did not get it to show on the oscilloscope. So let's see here. It's normal channel 1 volt per division. Okay, let's see, it's not triggering there, it's not seeing it. Okay, there it is. I needed to do an auto, and now I do a single, and now I do a normal. Okay, so why did it not see it? The trigger level was not set correctly, and so it wasn't actually seeing it. Okay, so let's try it again now. Now what would you want me to do? Okay, you would want me to say false like that, and man, that oscilloscope didn't go down, did it? Okay, let's say okay, let's try the auto mode there. The triggering, the problem is an oscilloscope wants to see an AC signal, so sometimes it doesn't see it real good when we are just doing single transitions like that. So let's try this again. This time we'll go true, and boom, you see it go up, and then we see the light come on, the LED come on, and now we're going to do false. And then boom, we see it. We saw that transition. We saw it come down. Okay, so the oscilloscope is working now. The LED is working. Universe is in proper order. Now I have to warn you, while we're fooling around with getting things set up, the oscilloscope might decide to kind of recalibrate itself or something. So the oscilloscope might be something we're going to have to keep tweaking, but at least you can see that voltage signal on the oscilloscope. Now, how do we start doing PWM? We have to create a PWM object for us to interact with. And so I am going to call my PWM object my PWM. You can call it my Lamborghini if you want to, but my PWM is a little bit more descriptive, and that is going to be equal to what? That is going to be equal to GPIO. That's what we named the library when we brought it in, .what? PWM. Okay, and now what pin do we want to be the PWM pin? We want pin 37 to be our PWM pin. And now what we have to tell it is what frequency. Okay, we have to tell it what frequency. For one cycle of our PWM, for our PWM signal, one cycle needs to happen at what frequency? That's saying how many times per second. Okay, now that's totally different than what percentage of that cycle is on and what percentage is off. That is a different parameter. That is duty cycle. Duty cycle is what fraction of the period it's on and what fraction it is off. That is duty cycle. We're not talking about that. For whatever duty cycle we're using, how many of those periods, how many of those chunks do we want a second? Well, a pretty good number is 100. So we're going to have 100 of these blocks, 100 of these cycles per second, and then inside of each cycle we'll define what the duty cycle is. I hope that makes sense. So we're going to use a frequency of 100. All right, and so now when we set that, look at that, it took it, and so now it is ready to go. And so now I'm going to say my PWM, and then I'm going to say start the PWM, and now I tell it what duty cycle to use. I tell it what duty cycle to use. Well, if we wanted something that was half brightness, we would set it at what? At a 50% duty cycle. So that should be on half the time, and that should be off half the time, and then it is 100 hertz. So let's try that. And shazam, look at that, boom. So what do we see here? We see a half bright LED, and then over here on the oscilloscope, we see that the pulse is on for half the time and it is off for half the time. Now that is duty cycle. We see the duty cycle, we see the impact on the LED. Now what we need to do is we need to kind of check and see if the frequency is right. And so what I'm going to do is I'm going to look at this, and you probably can't see it, but right here is where we start measuring, and right here there's a faint background grid that is 1 division. And so our cycle is how long? Our cycle, 1 cycle is 1 division. Well, what do we need to know? We need to know how long is a division, and the division, if you look down here, if you could see it, it says 10 milliseconds per division. So we get 1 cycle in 10 milliseconds. Well, if we get 1 cycle in 10 milliseconds, how many cycles could we get in 1 second? Well, it would be 100, which would be 100 hertz. Okay, so what have we verified here? We have verified that we have the right frequency. We have verified that we have the right duty cycle, and we have verified that we have an LED at half brightness. How cool is that, man? I love doing this, and I love operating here in the shell. I love operating in the shell, so it's like I'm right there down in those GPIO pins, and they are singing and dancing the tune that we are sending them. So that is pretty exciting. Okay, I think maybe you guys might see this better if I kind of turn the LED to the side. Sometimes it's really hard to see the LED, what it's doing very well. Well, that did not work very well. It's just these Sony cameras, these cameras do not like the LED very much. Also, the screen on the oscilloscope is actually very bright. It's actually very bright, and it's very bright colors, but for some reason the camera doesn't want to pick up those colors, and so I'm not sure. I'm not sure exactly what's going on there, but nonetheless, I digress. So okay, let's go down here. Now we started it. Okay, we started it. But you know what we can do? We can also stop it. So let's see if that'll stop. It didn't stop. Yeah, it did. Okay, there it is. Just took a second to stop. Okay, so it stopped. Now we could start it again, and let's just say that we did 10, like that. Okay, 10%. I did start again. Stop. Okay, start at 10. Let's see. Okay, boom, there it is. Now what I need to do is, for that, I need to make you see it a little better. So I'm going to spread that out. And then what you can clearly see there is, you can clearly see, let me make sure I got that right. Okay. Now you can clearly see there that signal is on for about 10% of the time. And then when you look at the LED here, you can see that the LED is very, very dim. Okay, so now you don't want to be starting and stopping, so I'm going to give you a new command. And what that new command is, you can simply come in here and change with an uppercase C, change uppercase D, duty cycle. Okay, so this is that kind of bumpy font, change duty cycle like that. And let's see if we can change it to, let's change it to 75. So we're going to be watching the LED and we're going to be watching the scope, and boom, look at that. Very bright signal on the LED. And you can see now that it's on 75% of the time. And so that is pretty cool. And I'm still wanting to get that oscilloscope working a little bit better. Okay, that looks pretty good. I think what I'm going to do is I'm going to expand that out a little bit like that. Okay, so now you can see one duty cycle really clearly, and you can see very clearly. You can see very clearly that it is. I need to. This thing is behaving a little bit like I got a little bit of glitchiness in it. Okay, that looks a little better. But what you can clearly see is in one cycle, which is 100 hertz, which is the cycle itself lasts 10 milliseconds. Okay, 10 milliseconds. 1 divided by 100 is 10 milliseconds. So if you want the period, that is the amount of time from the start to the end. The period of your cycle is 1 divided by the frequency. So if I have a frequency of 100, the period is 1 divided by 100, which is 0.001, which is 10 milliseconds. And so from here to here is 10 milliseconds, and it is up for 7.5 milliseconds, and it is down for 2.5 milliseconds. And I know I'm just kind of sitting here saying the same thing over and over, but I really, really want you guys to understand this. So let's go in and let's just take it on up to, let's say, 95. Okay, 95 like that, and clearly you can see that it's on for most of the time. And I don't think it'll actually work for 100. I think that it'll go to like 99, but I don't think it wants to do 100. Yeah, it doesn't. You know, if you want 100, just do a DC right on there. Don't do a PWM. So we could go like 99, and there, that would be the 99. Or we could come up and we could do a 1, change duty cycle to 1. Okay, and there you can see kind of it doing the other thing. What do you also see there? You see that the LED is very, very, you can see the LED is very, very dim. Also, I don't know if you can really do a duty cycle of 0, probably not. Yeah, it doesn't like the 0 and it doesn't like the 100. Okay, so let's go back to, let's make it a duty cycle of 5 and see. Yeah, there it goes. So that looks happy. Okay, now the other thing that you can do is, let me make it 50. Okay, let's make it 50 like that. Okay, that looks very clearly 50. Now you can also in the middle of this, you can change frequency. Okay, and what frequency? You can change frequency. If you can spell frequency, you can change it, but you've got to spell it correctly if you want it to work. All right, you can change frequency. Now, right now we're at 100 hertz. If I change it to 200 hertz, should that make the pulses spread out, or should that make them compress? Think about it. If I go from 100 to 200, should the pulses be twice as small, or should they be twice as big? Okay, they should be smaller. Okay, or now that was an unexpected result. So a higher frequency, this thing auto scaled on me is what it did. That was not a good demonstration. Okay, so if I go twice as fast, 200 hertz, then each cycle gets smaller, but then the darn oscilloscope rescaled on me. So let's go back now to 100, and hopefully at 100 hertz, things are happening slower, so those pulses should spread out. If it doesn't auto scale on me on the oscilloscope. Yeah, there it is. Now let's try going to 200 and see if we can do it without it auto scaling. Okay, now this should compress them together. Okay, yeah, that's kind of working now. That is looking pretty good. Okay, but now that we see that we can do that, I want you to watch the LED. Okay, and I'm going to go back to 100. Okay, and there, did you see any change in the LED? No, you didn't. What if I go to 1,000? Do you see any difference in the LED? No, you don't. Why don't you? Because you're not changing the relative time that it is on and off. It's on half the time, it's off half the time. It's just you're doing that a lot quicker at 1,000 than you are at 100. Okay, you're doing it a lot faster at 1,000 than you are at 100, but your eye can't perceive that at all. Your eye can't perceive that at all. And so let's go back to 100. Let's go back to 100 on the frequency. And remember, on all this, our duty cycle is 50%. Okay, so 100. Now let's just see, what if I went to 10? What might happen if I'm going 10 times a second? What is going to happen at 10 times a second is you're going slow enough that your eye can actually perceive that on, off, on, off, on, off. Okay, at 10 hertz, you can see the on, off. Okay, how about if we went to 20 hertz? So you wouldn't want to do 10 hertz because then you're actually seeing it. 100 hertz is a pretty good number to use, but what I'm trying to show you is the frequency that you use of your PWM really doesn't matter very much. So at 20, I'm still seeing it blink. At 30, I'm still seeing it blink. Yeah, I think you guys can see it blink too. Let's try. 40. Yeah, I'm still seeing a distinct blink. Okay, 50. I'm barely seeing it blink at 50. And then at 60, no blink at all. At 60 hertz, there's no blink at all. So it's still blinking, but somewhere between 50 and 60 hertz, the little neurons in your eye can't fire that fast, and it just says, okay, now I'm not seeing blinking, I'm seeing it half on. Now, what's the interesting thing about 60 hertz? You guys, somebody tell me, what is the interesting thing about 60 hertz? Your wall electricity, your AC wall electricity is what? 60 hertz. Why is it 60 hertz? So that when you are sitting there reading back in the old days, you know, with the old school lights, they don't flicker. That if they made the AC 60 hertz, you don't perceive a flicker in the lights. If you had the frequency lower than that, you would start perceiving a flicker in your light bulbs. Anyway, so I think part of the reason that you have 60 hertz electricity is so that you don't perceive flicker. And I think also, like the old refresh rates on televisions was about this as well. So it looked like you had a still image and you didn't see the screen refreshing itself. So just a little bit of trivia there. Okay, so now that is some pretty slick stuff. I'm trying to think of what else I could show here. I guess what we could do is we could come in, and it's always good when we're done to say my PWM.stop like that. Okay, and that should turn it off. And I think it turned it off, but then the oscilloscope grabbed that last signal. Yeah, now it's just reading nothing. And then always we need to GPIO dot clean up like that, so that we leave the pins clean for the next guy that might be coming in. Okay, guys, this is just really some pretty cool stuff. If you ask me, I think this is just some really cool stuff. So this is like a really, really huge step forward for us. So what can we do now? We can send signals to the GPIO pins. We can send standard on-off signals, high-low signals to the GPIO pins. We can read from a GPIO pin, whether it's on or off, and now we can send a simulated analog signal via PWM or pulse width modulation to the LED, okay, or to the GPIO pin, and we could control an LED, or we could control a motor, or we could control a thermonuclear reaction. The point is, once you can talk to the GPIO pins, it's like that is your pathway to the world. You can read from anything and you can write to anything once you know how to work with those GPIO pins. Okay, time for homework. Time for homework. What your homework is to come back to this circuit, okay? And what I want you to do is, from your most excellent Sunfounder Ultimate Raspberry Pi kit, I want you to get 2 of those little push buttons, okay? I want you to get 2 of those little push buttons. And with those 2 little push buttons, I want you to be able to control the brightness of the LED in, let's say, about 8 steps. And so you want to go from as dim as possible. You want to go from about as dim as possible to as bright as possible. And that might be like 1% to 99%. And I want it to increment like in 8 steps. So when you press the button, the first time, it comes on. If you press that button again, it goes up in brightness, up in brightness, up in brightness. So you've got one button that is making things brighter and brighter and brighter. And then you've got a second button, and that button is your dim button. So if you press one button, every time you press it, the LED gets brighter up to full brightness, and then the second button, when you press it, it begins to get dimmer. But I don't want you to just hold it, and while you're holding it, it dim, and while you're holding it, it brighten. I want it, each press of the button increments the brightness by 1 notch, and then each press of the other button dims it. But I don't want you, like if you think from 1 to 100, like if you think of 1% to 99%, I don't want you to have to sit and poke the button 99 times to get it to go up. I want, 7, 8, 9 increments to go from as dim as possible to as full as possible. Now, you might think about actually how to have it turn off at the lower one and how to have it turn to 100% at the higher one. But you're going to have to think about that a little bit, because I'm not sure that you can do a PWM of 0 and that would actually work. But you can play around with it. That would be extra credit if you actually go from off to 100%, if you can figure out a way to do that. But 2 buttons to have a brighter button and a dimmer button. How does that sound, guys? Does that sound like a pretty good homework assignment? I think it is. Man, this to me is just really getting exciting, because while an LED is not that exciting, what you got to see is that the point is, from our Python shell, we are controlling those GPIO pins. And what that means is, if we can control the GPIO pins, we can control anything that we hook to those GPIO pins. And so this is actually very, very powerful, what we are doing here and where we are going with this. Yes, as the lessons progress, we are going to start using more and more exciting components from the kit. But you got to learn the fundamentals with simple things like LEDs. That way, if you mess up, if you hook something up wrong, you burn out an LED. You don't burn out an expensive component. So we're going to learn the basics on simple things like the LED. And then we're going to start reading from some really exciting sensors, and we're going to start writing to some really exciting output devices. And that's where we're going. Hey, I want to give a shout out to you guys who are helping me out over at Patreon. It is your support and your encouragement that keeps this great content coming. You guys that are not helping out yet, look down in the description, link over to my Patreon account. Think about hopping on over there and hooking a brother up. Also, when you do this homework, if you are successful, leave a comment down below. I am legend. And if you're not able to do it, leave a comment down below. I folded up like a cheap Walmart lawn chair. If you did get it working, do a quick video of your homework solution, post it to YouTube. In your description, link back to this video, and then on my video down in the comments, leave a link to your YouTube homework solution. I go and I look at every single homework solution that you guys submit. I want to see if you're learning. I want to see if you're doing it right. I want to see if maybe you're doing something better than what I did. So make sure that you post your homework solutions. Also, in the comments, hop over and look at what other people are doing for their homework solutions. You guys start interacting and getting a little bit of a community going here. If you like the video, give it a thumbs up. If you haven't already, subscribe to the channel. When you do, make sure you ring that bell so you will get notified when future lessons are released. And then, as always, share this with your friends on social media, because the world needs more coders and engineers and fewer people sitting around watching silly cat videos. Paul McWhorter from TopTechBoy.com. I will see you guys later.